All right, let's go ahead and get started with some notes for limits by graphing. So, with the notation on the left, we have the limit as x approaches a from the right side of f of x. So what we're going to write here is where the function is going, or we'll just say where the function is headed, from the right side. So what I like to do is I like to use my hand and scan on the right side until I get to whatever value of a they're talking about. So this is going to be where the function is headed. From the left side. So you're always trying to approach A, it's just whether you're coming from the left side of the graph or the right side of the graph. Okay? Now the limit as x approaches A is basically asking where is the function headed, and it has to be from both sides. This can only exist, so this will only, in caps, really important, it will only exist if the limit as x approaches A from the left of f of x is equal to the limit as x approaches A from the right of f of x. Basically, it just has to come from the same part. So basically, if I'm standing on the left side and standing on the right side, I should meet, my two hands should meet at the same spot. Okay? So it only exists when it's approaching the same location. Alright? So now we'll move on. I don't know why I delta that. What's that? I don't know. Okay. Well, we'll just do. So now let's go through and let's look at this example. So this example says, find the following limit. So, for example A, it says, find the limit as x approaches -3 from the left. So we're going to go -3 is right here. And from the left, so we're going to scan from the left. Look at where my pen is. And it looks like from the left, it looks like this one is going towards positive infinity. Okay, because it's going up. Now for -3 from the right side, I'm going to, let me move down a little bit. So from the right side of -3, it looks like we have going down, 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 down as we get close to -3. So it's going to be negative infinity. Now, because A and B are not the same, so from the left for A, from the right for B, letter C is not going to exist because they don't go to the same place. Okay? Now we're going to go to the next one. Letter D says -5 from the right. So -5, that's right here. I'll do a different color. -5 from the right. So I'm going to scan from the right. Looks like it's going to 4. Then -5 from the left side. And looks like it's also going to 4. Now something that's really important is that it's always where it's headed to. It's not where it actually exists. So for these two, especially at -5, this open hole right here actually does not exist here, but it's all about where it's headed. Where is it approaching? Okay? So that means because D and E match, the limit does exist when you drop the left or right notation, and the answer would be 4. Okay? Now we'll look at letter G. Letter G says, as we approach x is -1. Okay? As we approach -1. So, as I approach -1, it actually looks like it's right here. Nothing weird. So we're just looking for the y value. So the y value is 0. No open holes, no different places. They're both going to the same spot, and that's 0. Now we're going to do the limit as x approaches 2. So if you look at the limit as x approaches 2, you have to check from the left and the right. So if you stand on the left side, it looks like from the left we're going to 1. And on the right side, I'm going to keep scanning and it's to 8. So that means that this one does not exist. Okay? Now we're going to check negative infinity. Where is this one headed as I head to negative infinity, which is furthest left? So we keep going to the left, and it keeps looking like it's getting closer and closer to 2, which seems to be a horizontal asymptote. Now for positive infinity, if I look on the right side, keep going to the right, we're going up. Positive infinity. now let's move on to the next one. So the next one's example, I'm going to go ahead and pause and I'm going to fill it in. And then I'll answer any questions that I think you might have. So go ahead and pause and see if you can fill it out. Okay, so now go ahead and double check your answers. So one thing that I do want to make sure to mention is letter F. Letter F is kind of like a special rule that we have to think of when we do it. So letter F, it says, as we approach -9. So as we approach -9, we're supposed to double check from the left side and from the right side. However, -9 doesn't have a left or right side. It has a right, but it just doesn't seem to have a left. So most times, or a lot of times, people might say that this one does not exist. The limit does not exist. However, when it's an endpoint of your domain and there is no further function to be found to the left, you can actually say that this limit does exist. So we're going to write right here. When we have endpoints of function. So when we have the endpoints of the function, only need one side of the limit. Okay, so only one. So that means that one would be okay. For example, if we asked you about 9, so if I said for k, let's say, I asked what's the limit as x approaches 9 of g of x, since the left side does exist, we could say that it's 3.75 or whatever you estimate that to be, without the notation for the left side, because we said it's the end point, so it's okay. All right? Whereas when we talk about 3 right here, this one is not an endpoint. It's not an endpoint, so therefore it does not exist because you need left and right. Okay? All right. Now, one other thing I wanted to talk about is what happens if I ask you. So we talked about -3 and the limit as g of x approaches -3. But what I'm wondering is, do you know how to do what is g of -3? G of -3. So I asked you the limit, and we said the limit was 5. But g of -3 is not 5. Look for your closed dot on -3. You're going to scan all the way down, and you're going to notice that it's right here at -6. So this is asking for the closed dot. Where is the dot closed? So where is my closed dot? Okay? The rest of them are asking where is it headed. This one is asking where is the closed dot. All right, let's check out the next one. The next one asks you to sketch. These are my favorite ones. So when you're sketching, you have a lot of options. So what you're saying is that you need it to head somewhere, but it doesn't have to be there. So it doesn't have to have a closed dot there, but it has to head in that direction. So that means as I approach 1, I need to be at 3. So one way to remember that is that 1, 3 is a point of significance. We have to make sure that we get there or near there. We don't have to have an open or a closed circle. It could really be anything. But 1, 3, we have to head there on both sides. So 1, 3, 1, 3. I can make it an open hole. That's fine. But I need to make sure that I approach it. So I get to make whatever I want. That's fun. And then that's fun. It's like a mountain range almost. Okay? But I approach it from the left and from the right, so everything is fine. I could even put a closed hole down here if I want to, as long as I'm approaching it as it asks me to. So that says the limit as x approaches 1, so as I get closer to 1 on the left and right, I'm supposed to be headed to 3. And that's exactly what I did. And you have lots and lots and lots of options. Okay? Now for the second one, it says as x approaches 4, we want to be at -2, or headed to -2. So 4, -2. All right. I think I'm going to do a closed dot there. Now I'm going to go like this. Now this would not be okay because I'm not done yet. Okay. So what I need to do is I have to make sure that on both sides I'm approaching. So I need to extend that. Okay? It doesn't need to be closed here, but mine I just happen to choose to close it. All right, next one. So your next one, it says at -3, we want -1. -3, -1, so I have to go around there. I could go there, but I don't really feel like it. 2, 1, 2, 1. I don't feel like going there this time either. Now I can do anything in between, but I just need to approach them. So one thing that I could do is maybe I'll make an absolute value function. Oh, that didn't happen. All right. And then I'll back up. And obviously I would make that straight, but unfortunately the laptop doesn't really let me to see that. Let's try again. Okay, that's at least better. Not great. Okay. And I could close one of those holes if I want to. I could put a close dot right here. And I could never close that one over there at all if I don't want to. So I'm going to pause and see what you can do for number 4 because we have a lot of different options. So this one I chose to make kind of boring. I just went through and made sure that it actually went through -2, 4, and then 3, -3. I have to approach. Okay, now this one is a little bit different because it says the limit as x approaches 4 is 2. So 4, 2. But then it states that g of 4 is actually supposed to be 3. So remember, this notation means close dot. Okay, that's a closed dot, and this just means the top one just means approaching. So we can do whatever we want here. So I'm just going to do, we'll do a quadrant. Good old parabola. Okay, now we're going to do the same sort of thing for 6, except for it asks you to make sure that it does not exist. So remember, does not exist means on the left side of this value and the right side of this value, you're not going to the same place. So it says g of -2 is 0. So we have to make sure that this limit does not exist. So one thing that I can do is I could go through and do that, and then maybe come up here and do, I don't know, a horizontal line. These do not come from the same place. So if I were to trace it with my fingers, I don't end up actually getting my fingers to touch each other. Okay? All right. Now we have this one. So this one talks about the left and the right. So this one says, as I approach 1 from the right side, I'm supposed to be up at 2. Supposed to be up at 2. All right. Then it says, as I approach 1 from the left, I'm supposed to be at -2. All right. Oh, geez. Okay. Oh, wow. Okay, well, that's supposed to be straight, but it's fine. Okay, and then it doesn't actually tell me I have to fill it at any point in time, so I'm not going to, since I don't have to. Now let's double check what the next one says. So the next one says it wants -3 from the right side to be at 5. 1, 2, 3, 4, 5. This one I'm going to close just because I feel like it. This one's also going to be a parabola. And then it says -3 from the left side, it's supposed to be at -4. 1, 2, 3, 4. Now I can't close this one, that wouldn't be a function, so I'll leave it open. And I'm going to do an absolute value function. Beautiful. Okay, so that's how you go about doing limits by graphing. I hope that this was helpful.